Hello everyone. After having understood the construction of histogram, when class intervals are equal, when class intervals are unequal, when only midpoints are given, now we move on to the construction of histogram when class intervals are in inclusive series. So let's understand how is it done. In order to understand the construction of histogram when class intervals given are in inclusive series, let's take an example of this illustration on marks obtained by students and number of students. One can notice that marks obtained are in inclusive series of class intervals and number of students are frequencies. So let us understand step by step. First step would be to convert the inclusive series into exclusive series. Although you have done this earlier, but we shall repeat. Notice the upper limit of first class interval, which is 14, and lower limit of the second class interval, that is 16. The difference between the two limits is 2 and half of the difference is 1. So to convert it into exclusive series, we need to make some modifications. Lower class limit of exclusive series would be lower class limit of inclusive series minus half of the difference, and upper limit of exclusive series would be lower class limit of inclusive series plus half of the difference. So that would be first class interval lower limit is then 6 minus 1, which is 5, and first class interval upper limit would be 14 plus 1, that is 15. So the class interval would be 5 to 15. Similarly, one can find for rest of the class intervals and have a look at table 7 here. Marks obtained by students then becomes in class intervals like 5 to 15, 15 to 25, 25 to 35, 35 to 45, 45 to 55, and number of students as it is, the frequencies 5, 12, 20, 10 and 3. Now have a graph paper and value of the variables which are independent taken on x-axis like marks obtained by students, and dependent variables like the number of students would be taken on y-axis. Frequency will be depicted as a vertical rectangle converted to scale from x-axis for each variable value. Then you need to select the axis and have scales. Scales should be selected in such a manner that the values of the variables to be represented on that axis are covered within the axis length of 5 to 7 centimeters. For x-axis, you need to select a scale. Say each of 5 marks can be represented by 5 mm point, like A as shown on x-axis on the graph. So scale would be 5 mm is equivalent to 5 marks for x-axis. Similarly, for y-axis, one can select 5 students to be represented by 10 mm and is shown by A dash on the graph on y-axis. So scale for y-axis would be 10 millimeters represent 5 students. Then you need to decide for the length of x-axis. Length of x-axis depends upon the bar width. So you need to take into account an assumed bar width. You need to know the number of bars to be presented here. That depends on the number of class intervals. You need to decide for margins on the left side of the first bar and right side of the last bar. So reasonable width of a bar is assumed to be 10 millimeters. Side margin 5 millimeters, whether it is left side or right side margin. Number of class intervals are 5, so there would be 5 bars. So the total length of x-axis would be width of the bar, which is 10, multiplied by number of bars, which is 5, plus the left side and the right side margin, which is 5 each, that makes it 60 mm, or it is 6.0 centimeters. So length of x-axis would be 6 centimeters. Similarly, one can find the length of y-axis. Here maximum number of students are 20. Margin for students, we have assumed 5 students. So highest scale marking on x's would be 20 plus 5, that is 25. So the scale is represented by, as we have decided, 5 students represented by 10 mm. So length of y-axis would be scale of students in millimeters divided by number of students into maximum students, which is 10 by 5 into 25, it is 50 mm, and margin is 10, so total length of y-axis would be 60 mm or 6 centimeters. Then you need to take a graph paper and select O near the left side of the graph paper so that both the axes can be accommodated on graph paper. One can have on the left side with a distance of 10 millimeters as is shown. So you need to draw a line from O as OX, which is 6 centimeters long. It is a horizontal line. Then vertical line also from O representing the number of students, which will also be 6 centimeters. Then you have to mark the marks obtained by students on x-axis. So scale is already known to us, 5 marks equivalent to 5 millimeters. So starting from point O, mark 5 at the distance of 5 millimeters as is shown here, depicted by A. Then 15 at 15 millimeters, and so on till 60, simply because the maximum marks are in the range of 45 to 55. Then you need to mark the number of students on y-axis. Scale we have already decided, 5 numbers of students represent 10 millimeters. So starting from O with a distance of 10 millimeters, mark 5 as a dash shown here, and then mark 10 at 20 millimeters and so on till 25, because the maximum number of students are 20. Now you need to plot first data point to make a histogram. We have seen that first class interval is 5 to 15 with 5 students. So we have points A and B representing 5 to 15, and you can mark a point C at 5 on y-axis and draw a vertical line to meet horizontal graph line from C at point D. From point B, draw a vertical line to meet the horizontal graph line from C at point E. So join these points D, E to complete the rectangle A, B, E and D. This rectangle represents first data point representing class interval of 5 to 15 with number of students as 5. On the same basis, you can make other bars and complete the histogram. And that is how one gets a histogram when the class intervals given are in inclusive series. I hope you have understood all these steps, though you must have found that the steps are similar, whether it is histogram with equal class intervals or with unequal class intervals, or with midpoints given, or when the series is inclusive. The only difference in each case is to make adjustments if it is unequal class interval, if it is midpoint, or if it is inclusive series. Once that initial adjustment is made, then the steps are similar. Following these steps, one can construct the histogram. So with this, the portion on histogram gets complete. Next time we shall discuss frequency polygon. Till then, keep learning and keep practicing. Thank you. To learn more, visit our website and enroll in our courses to master economics and get a higher score in CBSE and CUET examination. With our current introductory offer, you can enroll in each of the courses for just rupees 999. So, seize the opportunity and join before the introductory offer expires. Like, share and subscribe to Ecostudys channel. Also, drop a comment. See you in the next session for another concept. Thank you.